Thank you all for coming out tonight. So I just wanted to give you a little bit of background on both Chuck and Gordon before I let them start. So Chuck is a retired meteorologist and an airline pilot, and he has a wealth of knowledge to share with us tonight. He is a Bachelor's of Science degree in Atmospheric Science. Wow, that was a good word, huh? Mathematics minor from Oregon State University. He knew well the founder of the Oregon chapter of the American Meteorologist Society and the late Dr. Frederick Decker, who developed the atmospheric science major at Oregon State University and for whom he studied under in his major. He has 16 years as a broadcast meteorologist for stations at Coin TV in Portland, WCCO TV in Minneapolis, St. Paul, Minnesota, and King TV in Seattle, Washington. He holds a U.S. patent for the first of its kind instrument called a windicator. In 1987, Chuck switched careers and became a professional pilot for Horizon Air. He also worked for Reno Air, Northwest, and Delta, logging in over 15,000 hours. He is now retired, but he still flies his own plane and educates the public. Now, Gordon, another brilliant man that's with us tonight, has a PhD in physics from the University of Chicago, is on the board of directors for the CO2 Coalition. He is an astrophysicist. Dr. Fulks' background is similar to that of a scientist promoting AGW, and I had to look that up. You all might not know either. Anthropogenic, is that right? Yes, I am learning big words tonight, people. We are really learning big words. With notable exception, he has never accepted any money to promote or oppose any theory because it's unethical, and he is considerably more experienced than most who have. Dr. Fulks has worked for a think tank in Santa Barbara, California, supporting the U.S. Defense Nuclear Agency on nuclear weapons effects. More recently, he has consulted for businesses and government clients seeking to better understand electromagnetic phenomena, related scientific scares, and the concept of accessible risk. Dr. Fulks is an avid mountaineer, caver, orchid collector, and tree farmer. He has climbed most major peaks in the Cascades and the High Sierras, and several major world peaks. He has also explored many caves, including the deepest cave pits in the world located in central Mexico. He has an extensive orchid collection and grows many trees, including 360 sequoia giants. These gentlemen here tonight are here to educate us. So I want to go ahead and introduce Chuck first and let him start.
Thank you very much, Tracy. It's a pleasure to speak to you folks tonight. This climate crisis is phony. It was phony from day one and it remains phony today, and this is why I came here to talk to you guys a little bit about it tonight. To share with you some of the information that nobody talks about today because of how it's been politicized so much and changed over time. The people of this state are not interested in carbon taxes. We are not interested in doing anything that's not going to help the public. When I was an undergraduate student at Oregon State University, that brings the clock back to the 1970s. I knew, as in my introduction, that the founder of the entire atmospheric science program was the late Dr. Frederick Decker. All the work that was done back then, post-Einstein, in quantum mechanics and radiative transfer through the atmosphere that defines how the greenhouse gases work, this was all done post-Einstein, and the founding work had shown us years ago, when we studied this major back in the 70s, that the greenhouse gases and the role that they have in the atmosphere, particularly CO2, is non-controlling on anything with respect to the planet. We have a lot of empirical evidence to back that up, and what's changed since that time is only one thing: the advent of climate models. And I watched the transformation of Oregon State's undergraduate program and graduate programs in atmospheric science through that transformation, because back then they wanted to take atmospheric science from where it was and transform it into being able to tell us what the climate will look like far into the future. The big push back then was climate modeling. We will be able to tell you folks what the climate will look like 100 years from now. At the time they were doing that, I didn't know that this CO2 business was starting. I thought to myself, that's a noble objective, but we also knew what a monumental task it was going to be able to accomplish that goal. Today it hasn't been accomplished at all, but the models, and I call them today the Oz machines, because I think it's the Wizard of Oz. Remember when they scared Toto and Dorothy, the big mean Wizard of Oz? Well, it's just a big embodiment of a model that puts out a bunch of output, but nobody really knows the secrets contained within inside of it. And it projects that as you cause CO2 to rise in the atmosphere, the temperature will go up. There's all kinds of reasons why that wouldn't work. I won't get into all of that tonight. But I wanted to start before the presentation too, to give you guys an example of how badly the university system has politicized this. Now, some of you might have already seen this. I'm not sure. I brought it with me tonight. It's a full-page ad that was taken out in the Oregonian. This was last March, just before this big push to get HB 2020 passed. What's the substitute for that now, Ellen? What's the name of it now? LN something? LC19? Okay. This is when they were pushing HB 2020. This was a full-page ad that was taken out by the Union of Concerned Scientists in March 10th, Sunday Oregonian. This is last March, almost a year ago now, coming up on a year ago. It was signed by 70 university professors. And these guys made a false statement about the climate in taking this ad out. And I thought to myself, good grief. You guys got PhDs and you would sign this sort of nonsense? The Union of Concerned Scientists is not a scientific body. It's a political body based in Washington, D.C. And this ad, I'm sure, costed probably $10,000 to put in the Sunday paper full page. But it makes this outrageous statement that, there's this letter here addressed to Governor Brown, dated March 3rd. Dear Governor Brown and the Oregon Legislature, they go on and on about, we're in a climate emergency. We demand that you take decisive and definitive action to control the climate and get things back under control. And they made a statement in here that clean energy jobs, which they refer to as HB 2020, if they pass it, they claim it will overcome these challenges about the climate. It will reduce global warming pollution across the state and invest in clean energy and protect, here's the thing, protect our communities from the impacts of climate change. That is a lie. I was so upset when I read this, not just because I know that it's a lie. One of the professors who signed it, I had an email exchange with back in 2014. His name was Christopher Butenhoff from the physics department of Portland State. Because they were talking about this back then. And we exchanged ideas, and I showed him some simple carbon calculations, and I said, you know, I don't understand, Professor, why you guys are talking about a carbon tax for a place like Oregon, because even if you believed the nonsense of Al Gore and these phony computer models that don't work, it's physically impossible by passing any legislation in Oregon to change the atmospheric CO2 composition or the climate, because they go hand in hand. You can't separate them. Now, Professor Butenhoff agreed with me. Sent an email back. I still have it. And he said, you know, you're right. So I asked him, why are we doing this? He goes, well, they're just kicking some ideas around and asked us for some input, so we gave it to them. But I agree with you, it'll have no effect. Then, 4 years later, here's his signature on this full-page ad. So I wrote him again, and I said, I thought you and I had this thing settled 4 years ago. What's up? Why did you sign this? Silence. He has not answered me yet today. Now, there's only one reason why he wouldn't, because he knows he fell onto the political side of this, which is unfortunately what the university system has done. So, this just gives us a kind of a broad picture of how bad all of this has become politicized. And why would these guys do this? Because they're money grubbers. If you pass HB 2020, they get part of the spoils. So they've reached a point, unfortunately, where at least in this area, they don't care what the truth is anymore. That's very, very unfortunate. So tonight I'm going to present a little bit of work because there was some very important things that have been discovered about carbon dioxide since we got into this business of claiming that it can change the climate. That absolutely proved that it's not having this effect. Not only because the initial work showed that it doesn't, but because the amount that we put in the atmosphere is minuscule compared to nature. And there's a physicist by the name of Dr. Edwin Barry. Gordon and I know him well. He lives in Montana, but he decided to look into the IPCC's claims that everything that's going on with the concentration of carbon dioxide in the atmosphere is all human caused. There is nothing else that changes it except humans. Ed decided to look into the work that the IPCC did with this, and of all the things that they can screw up, I figured, well, they wouldn't screw that up, would they? Well, they did screw it up. Ed looked at their work, and it's just an abomination of science, like so many other things that they've done. And they have no real good reasons why they did what they did, but I'll expose through this work why it's faulty and why we really don't control what's in the atmosphere, and we certainly don't control the climate. To start the presentation, though, tonight, let's take a look at the logic that people use today when they want to talk about climate change. Now, I'm not talking about scientists like Gordon or Ed, or those of us meteorologists who understand some of these issues. I'm talking about the political class and how they look at the world and their myopic, non-scientific world. Their logic is, if human CO2 changes the climate, then bad stuff will happen. How many times have you heard that on television? All the time, all the time. If CO2 is changing the climate, bad stuff will happen. What do they mean by bad stuff? Well, it could be a hurricane, might be a tornado, might be a bad snowstorm, might be a bad windstorm, might be a heat wave. Anytime things like this happens, these people say, bad stuff's happening, therefore CO2 changes the climate. Can you see the disconnect and illogical thinking here? But this is what these people do and how they sell their argument. They have no proof to tie the two together, but they insist that because of this sort of logic that CO2 is changing the climate. Events don't prove their cause. An example of this is, if Bill Gates owns Fort Knox, then he's rich. Well, if the gold is still in Fort Knox, that's a truism. So they say, okay, Bill Gates is rich, therefore he owns Fort Knox. This sort of inverted logic is how climate science today has been politicized and being taught to our children, to any sort of public group that will listen to these crazies who want something out of it. So tonight, we'll talk a little bit about what's the differentiation between that and the scientific method. Well, if you're doing good science, like Ed does, like Gordon does, you're a true physicist, true meteorologist, you have data, and with the data you ponder things, and you see the data is changing something, and so you think to yourself, I wonder how this behaves, what causes the changes. So you make a theory with the data. So on the left-hand side, your data goes up to theory, and with your theory, you can make a prediction. How matter behaves, how something will change through time. The key is, then you have to take your prediction and check the data again at some point later on. And the question will be, did your prediction come true? Can you validate it or can you not? If you can't validate it, on the bottom, if it's wrong, your theory is wrong. End of story. One of the most famous physicists that Gordon will refer to tonight, Richard Feynman, made this statement. Science is as simple as that when it comes to deciding whether you got something usable or whether you got to go back to the drawing board. In the case of CO2 changing the climate, these guys didn't cut it. I'll show you why a little bit later when we take a look at some of the accuracy of the climate models. So we'll start tonight by examining Ed Barry's work, because Ed came to the conclusion that we don't change CO2 enough in the atmosphere to make any significant difference to the climate at all. But when we talk about CO2, how many times have you heard everything we're putting into the atmosphere is causing this rise in CO2? Isn't that what they're selling us? They take a look at how many parts per million are in the atmosphere. Every year it goes up. And they're saying it's fossil fuel burning only that's causing this. Nature has nothing to do with it. Well, what a bunch of baloney that is. Here's the actual carbon cycle that a lot of people don't realize. It's what humans put in, and it's also the exchange between the biomass and the land and the oceans that goes in and out of the atmosphere every year. What a lot of people don't realize is how large that is compared to the human input. Nature's yearly carbon cycle is about 100 times greater than what the human contribution is. People don't realize that, but that's the truth. If you take a look at photosynthesis, the in and out process from land, 110 gigatons per year goes from decay into the atmosphere, and the trees and plant life around us absorb about the same amount back. Not all the time. Then look at air-sea exchange, 92 gigatons. It's a huge amount that comes out of the ocean and then back into the ocean. Some of it into the land. Fossil fuel emissions is only 7 gigatons. That's almost 2 orders of magnitude smaller. It's very small compared to this. Now, what the IPCC does to get away with saying we are wholly the cause of how atmospheric CO2 is going up is they claim that these processes from photosynthesis and the air-sea exchange are constant. They never change. Is that believable? Of course it's not. Anybody who knows how CO2 comes out of a Coke bottle or 7-Up, a carbonated beverage, knows if you heat that beverage up the slightest amount, the CO2 will want to come out right away. It's temperature dependent. So if the climate's warming, these balances, which are probably fairly accurate as initial assessments, are going to be changed. And they can easily overpower what humans emit with the burning of fossil fuel. So we'll get into looking at some of Ed Berry's work. So here's the atmosphere. There's our 900 gigatons of carbon that's in it. Below we've got the oceans and the biosphere. What the IPCC does with their model is they claim that none of this changes with time, but the absorption rate out of the atmosphere depends primarily on one thing. It's partial pressure of the gases over the ocean. But the IPCC has 4 absorption drains, and I'm referring to the atmosphere when I talk about that. It each has its own atmospheric proportion and rate of absorption. Why would that be? Nature doesn't know the difference between a carbon 12, 13, or 14. It doesn't know the difference, but yet they treat it like this, and these bins are each filled to 100%. The first one has what we'll call A sub 0. 15.2% of the total goes into that bin. The second one, 25.3. The third, 27.9. And the fourth, 31.9%. They don't explain why they did this. And then they got 3 residence times. The residence time is how long it actually stays in the atmosphere. They got one time at 173 years, another time at 18.5, and the third time at a little over 1 year. And one of them in the bottom here on their equation, I won't go into the details of it, but A0 has no time dependency attached to it. So what they're trying to tell us is this bin over here never leaves the atmosphere. It just stays there forever. And Murray Salvey, who's also looked into this problem with Ed Berry, he's a PhD from the University of Colorado, said, if someone working on a PhD thesis wrote an equation like this, they would flunk their PhD thesis. Because you're saying that one part of this never leaves the atmosphere. It lives forever. And there's no such thing as a CO2 molecule living forever. It's completely flawed from the beginning. 8 years later, here's bin 1, still 100%, bin 2, 98%, bin 3, 81, and this is the only one that has any semblance of normal. Now, why did they do this? Because they want to stack CO2. The only logical answer is they want to stack CO2 in the atmosphere to where then they can make the argument that the smaller contribution we make is actually what alters the total. They don't want to tell you that the amount actually getting cycled through is much larger than that. To make it worse, There's no physical data that backs this up. It's something they concocted. It's wrong. Simple as that. It doesn't make any sense. We know it's wrong because Hermann Hardy is a German physicist who also wrote some papers about this. I read his work. And he's shown, along with Murray Salby, that there's a strong temperature dependence to the amount of CO2 that goes into the atmosphere. He graphed it out using data that he had. On the top is the amount of CO2 in the atmosphere in parts per million. Across the bottom is the temperature in Celsius. And down here, close to 10, is a glacial, when we were in an ice age. Pretty cold global temperature. As we came out of the last ice age, notice the CO2 increases rather rapidly. These are the years from 1850, 1960, 2000, and 2020. If you look across here to the left, the amount of CO2 in the atmosphere is almost exactly in time based upon this temperature dependence where we're at today. And it's an exponential curve, it's not linear. That's what Ed Berry's work will show you now as we go to that. The correct model that Ed derived, here's our 900 gigatons, and we start with the nature's contribution of CO2. That's called the inflow. It's our 216 gigatons, which is what cycles in and out on a yearly basis. And then I drew one drain here, not four, because nature doesn't know the difference between these isotopes. They don't know. It all gets absorbed out of the ocean in one drain. Then the human contribution of inflow is our weak 9.8. That's all humans put into the system. And human inflow is independent of temperature, but this is absolutely dependent upon the temperature, because as it goes up, the amount going out is the sum of both of these, and the amount going out on the nature side will go down as the temperature goes up. More outgassing from the ocean, less absorption. So as the climate warms, that's why you have this exponential increase in the amount that's actually in the atmosphere. It's temperature dependent. Only what we admit is not dependent upon the temperature. It can be to some degree in the wintertime as we burn more fossil fuel, but that's about all. So the outflow depends on both of these partial pressures into this one bin. So how do we develop a model from this? Well, Ed just developed a simple two-box model. I'm not going to go into the math details. If any of you are mathematicians out there, you can look on Ed's site. He derives all this for you, and you can follow through on it. But the point is, a simple box model says dr over dt, which just means the rate that the level R up here in the atmosphere changes with respect to time is simply equal to how much comes in minus how much goes out. A very simple concept. He derived the equations from that, and the result he got is the analytic solution of the equations allow the variables that are the level R, time, and the balance level to be determined. And that he did very well. Now the problem is, we know the IPCC's data was, it's wrong. They don't have anything to back it up with. Remember what I said at the beginning, the key to science is you gotta have data to back up your theory? So, how do we know that Ed's model here is correct? Well, we rewind the clock back in time. Some of you probably remember this, but you go back to the early 1960s. Back then, during the Cold War between the Russians and the Soviets back then in the United States, nuclear weapons testing was going on all the time in the atmosphere. You remember that? Russia was blowing up nuclear bombs on a regular basis with atmospheric testing, and we were too. One of the last ones they did was called Tsar Bomba. And I think it was in 1962. Nikita Khrushchev wanted to send a message to the whole world, don't mess with us Soviets. We have the most deadly nuclear arsenal in the world. And he had his scientists develop a 50 megaton thermonuclear bomb. But the damn thing was so heavy they could barely get it into an airplane to fly it out over the Arctic Ocean where they had to detonate it. But he finally got him to do it. The pilots almost died coming back. but it was the biggest nuclear explosion ever in the atmosphere. And because they blew it up over the Arctic Ocean, the environmentalists were outraged. It caused international outrage. And the shock wave was so powerful from that explosion, it went around the world. Gordon's father was the chief meteorologist of the Chicago Weather Service back then. And we tracked pressure with microbarographs, which give us a running recording of how the atmospheric pressure is changing. That shock wave was registered on the microbarographs as far away as Chicago. That was one heck of an explosion. Well, think about it, 50 million tons of TNT. But anyway, the outrage caused the United States and the Soviets to think that, maybe we better do something about atmospheric nuclear tests. They developed a test ban treaty, and they stopped the detonation of these atmospheric nuclear tests. The chemists, though, seized an opportunity from this, because when you blow up a nuclear bomb, like you get nuclear reactions at the top of the atmosphere from the sun, you create a different isotope of carbon. It's 14, but it's only found in these kind of reactions. Ed took that data, which the IPCC should have done, and used it in his model to see if his equations matched the predictions of what was observed and how this was absorbed into the environment. Back in 1955, when the testing was going on, you can see the percentage of normal carbon went way up, all the way to the test ban treaty, which was reached on the 10th of October, 1963. These measurements are for Wellington, New Zealand, and Bermondsey, Austria. The half-lives are not nuclear half-lives, they're just half-lives of the amount that's in the atmosphere. 100% is normal, and it reached almost 200% of normal when the testing was going on. And then after the test stopped, almost an inverse exponential decay or absorption of the carbon-14 into the environment. So what Ed did was, he took this data, it's been around for a long time, and he plugged it into the equations he developed. This is what he got. The little dots along here are using Ed's equations to model the New Zealand carbon data. And the absorption of 14 carbon fits exactly into Barry's physics model if the E-time is set at 16.5 years. One E-time reduces the amount to about 36%. It's nearly a perfect match. If he took everything, all the other data from all the other sites and did it, the exact fit comes in at 14.4 years. One E-time or one E-fold, when all of this is absorbed down to 36%, is at 14.4 years. The blue line is a perfect match. Then he took what the IPCC did with their equations. Look at this. That really sucks. It's wrong. Completely wrong. It goes way off the charts over here. So the IPCC's idea of how carbon is absorbed out of the environment are wrong. And if they're wrong taking it out, they're wrong with their answers and how we're solely responsible for putting it in. He also did some calculations for carbon-12. That's often associated more with the direct burning of fossil fuels. And the E-time here, which is based upon 4 years, and that, by the way, is what the IPCC claims is a valid calculation, 4-year residence time. You're down to 36% in 4 years, and it drops rapidly after that. Now this assumes no carbon's coming in, right? This is 14. Once we stop the testing, this is how fast it's all going out of the atmosphere. But Ed's equations are the only ones that successfully model this. And so it proves the IPCC is wrong. What are some of the consequences of this? It's a fascinating thing that Ed Berry did. Well, if you read these equations, recall the balance level we defined as RB is defined, if you look at the equations more carefully, is how much is going in times the residence time. That's how you define the balance level. The balance level means you reach a point where so much is coming in, so much is going out, and for a while, the amount going in exceeds the amount going out until you reach the balance level, where they both equal each other. And so you can figure through its equations what the balance levels are going to be. Nature's portion of atmospheric CO2 balances them. This is from the IPCC and from those graphs that I showed you. 98 parts per million per year times 4 years is 392 parts per million. That's the part that nature has put in. The human, or anthropogenic portion, is 4.5 times 4 years, or 18 parts per million. That's our portion, not 410 like the IPCC tells you. The sum of the two equals, it must equal, the total, which is 410. Nature, anthropogenic, 410. The human component of atmospheric CO2 then is only 4.4% of the total in the atmosphere, not 100. The IPCC is wrong. So I took this, and I took that data and I plugged it into a CO2 model that's run by the University of Chicago. They call this their Modtran radiation code. And if you plug our portion of this just into that, which only considers the effect of CO2, you get 0.06 of a degree centigrade, or 0.16 degree Fahrenheit change in temperature. That result, compared to how we're able to track the temperatures, is completely within the range of natural variability of the Earth's temperature. In other words, it's trying to look for a needle in a haystack. You can't find it. We're not responsible for climate change. That's using their stuff, not using the founding work. Now, to back up the temperature sensitivity things that we talked about, which also kind of mirrors Hardy's work and what Murray Salby did, notice how much CO2 enters the atmosphere if the residence time is perturbed by a temperature change, by increasing in only 2 years. Now we take 98, which is what the IPCC says nature's portion is, but if we multiply it by 6 years, we get 588 parts per million. The human component then would be 4.5 parts per million times 6, or 27, and the total is 615. So by just small changes in global temperature, the total in the atmosphere can rise from where we are now all the way up to 615. Doesn't take much of an effort to make that change. But the fraction of human to natural emissions doesn't change from 4.4% unless human emissions continue to increase to a new balance level. That's very significant. And it completely disproves these assertions by the IPCC that we are controlling the climate or the amount of CO2 that's in the atmosphere. Now they also claim that we know we're right because the ratios of 12 to 13 will go down if you're burning more fossil fuels. So that's what the saying goes. They base that on the fossil fuels contain more carbon-12 than 13, so if you put more of that than the natural part that we find in the atmosphere, you should see the ratios falling. And they do fall. But the problem is, with that, this is Murray Salby's work. CO2 and temperature track very nicely as they go up and down with each other, but carbon-13 does not. What we actually find is that it's inversely proportional to temperature. So 13 goes down as the temperature goes up, which means all bets and their assertions are off. You can't rely on this. They should have checked it, but they didn't. And satellite measurements show the same thing. Poor anti-correlation, poor correlations to this, and so we know by just looking at this data that you're able to get, we're able to get off satellites now, that these ratios they use to try to prove that humans are the cause of the rise in CO2 are unreliable. They're not proved at all because they didn't check their facts. Here's another thing that is pretty much proof that the IPCC is full of baloney when they say that we control the amount of CO2 in the atmosphere. Because from right after the year 2002, and this is primarily from the Chinese, the amount of fossil fuel burning tripled. Here's the least squares going from 0.0 to 0.14 after 2002. You can clearly see the linear slope has changed radically upward after the year 2002. Yet, the atmospheric CO2 increases measured at Mauna Loa stay virtually unchanged. That would be impossible if humans were the ones causing the changes. Nature is taking the small contribution we give it, and as temperatures have been rising some, that's easily absorbed into the environment, and they're controlling more of what comes out than we are. That's why you can't find this signal anywhere on the Keeling curve or the data as it's derived from Mauna Loa. The conclusion from this, just by the CO2 work, is obvious. We don't control CO2, and if we can't control CO2, even if you believe the nonsense from the IPCC, we can't be controlling the climate. I'm going to get into a little bit of discussion here too about how the greenhouse gases work, because they're so misunderstood. People just do not get this down right. But to give a perspective of how weak CO2 is as a player in this whole thing, you have to take a look at the whole spectrum that it absorbs and emits radiation at compared to everything else. At the top here is the radiation we get from the sun. Its peak is at about a half a micron. The Earth emits these curves here. And this area in blue is called the atmospheric window. That's where there's no blocking mechanism by the greenhouse gases or the radiation trying to leave the ground at those wavelengths, which peak right near 10 microns. But if you look below that, here's total absorption and scattering. These are inverse relationships to this. You see how this area here, you transpose it up to this curve, and all of this here? All of this area in white on the top curve here is being absorbed by what, primarily? Look below that line. Water vapor. Look how powerful that is. Here's CO2. Here's water vapor. Look at how widely it absorbs and emits radiation across the infrared spectrum. It's even getting into absorbing near infrared and energy from what the sun is putting out. So the sun actually can cause direct warming of the atmosphere by these molecules absorbing in the near IR that the sun puts out to the earth. Then water vapor is completely absorbing all the IR except around the window. Carbon dioxide only gets a small part, and notice below there, it shares a lot of what it gets with water vapor. It can't even control, except over a very, like right at 15 microns, it might control a little bit, but that's about it. It shares the rest of it. So it's like saying, just by this eyeballing this chart, it's like saying the tail is wagging the dog. It's impossible. And the role in the atmosphere of these gases, water vapor is the blue line here. The red line is if you add CO2. It's how the temperature changes at the ground. The temperature at the ground is across here. And here is height, going up to 60 kilometers. The tropopause, or top of the troposphere, is about right where this line bends out. And the reason why it does is because ozone is absorbing solar insolation, solar energy, and it causes a lot of warming up here. They say here that carbon dioxide would warm 10 degrees, but what's missing from this picture? What's missing from this picture is a hydrological cycle, the formation of clouds and precipitation. That's not included in this graph. So it's unfair to say, just looking at these constituents individually, that you're going to get 10 degrees of warming out of CO2. That would only be true if it operated by itself. When you mix water vapor in, it changes it because water vapor condenses, forms clouds and precipitation. Thermodynamic properties of water vapor completely rearrange the optical depth of the troposphere. And then when we talk about how these greenhouse gases work, how many times have these people that think they know how it works said to you that when you put something like CO2 into the atmosphere, well, that causes warming. Say the air temperature is going to warm right away, and it's from a direct consequence of putting the CO2 in. That's completely false. It's not how it works. The greenhouse theory works by these gases trapping radiation trying to leave the surface. The greenhouse effect is realized at the ground, not in the air. All the radiation from these gases is absorbed very close to the ground. High above the ground is simply emitting radiation at its own temperature back at the ground. And the effect from that is the gases cool the troposphere. They don't warm it, they cool it. The trade-off is the warming is realized at the ground because the gases absorb enough radiation to where all other things unchanged that is, with solar insolation. When you reduce the amount that can get out to space, the temperature at the ground will have to become warmer. And then that heat energy is transferred back to the troposphere. But it creates a convective loop. It's like heating water on a stove. The bottom part of the pot's very hot. The top part is not as hot. You're getting a lot of overturn. The overturn creates the clouds, the hydrological cycle, and guess what that does? It blocks the incoming solar insolation and regulates the temperature that way. The net effect of having water vapor and CO2 is on this black line. This is a heating rate per day, and if it's less than 0, it's cooling. So they're trying to, the greenhouse gases take heat energy out of the troposphere. The only thing that warms is shortwave water vapor. That is the energy from the sun because of those spikes I showed you in the near infrared. It can actually cause a warming effect. Other than that, it cools and the trade-off is at the ground. If you've got water locked into this, you cannot change this from CO2. That's what's going to happen if you add more CO2. You're going to increase the cooling rate of the troposphere, which limits water vapor more because water vapor, the way it works is, the colder the temperature, the less water you can hold in the air. The less water in the air, the more radiation is going to get out. This is how it maintains this constant balance. You're being completely misled to be told by adding CO2 you're having a direct warming effect to the troposphere. It's not how it works. Now, I never end a presentation without an opportunity to crap all over these climate models. I absolutely enjoy doing this because they're overrated heaps of junk. They're Oz machines. And what's the proof that they're Oz machines? The record. Contrary to the very physics model of CO2, climate models fail validation and remain unphysical. And the record shows this. This record starts when Jim Hansen first made his prediction using one of the first climate models that was invented. Goes back to actually 1988, but he ran it back to the early 60s and then projected it forward in time. He had 3 scenarios that he used to make his temperature predictions of the Earth's atmosphere with. The first is where we actually are now, the green line. The green line assumed that this is business as usual. We've even exceeded it. Business as usual means we continue to pump CO2 by our own emissions into the atmosphere, increasing at a rate of 1.5% per year. It's actually tripled. And look where he said the temperature would be by the year 2015. Up to almost 1.3 degrees above the established 30-year mean. His scenario B was a moderate reduction of greenhouse gases. Like we already had these so-called mitigation things in place, which we don't. It predicted we'd be over a degree above average, above the 30-year mean. And C was a drastic reduction. It's like we had carbon legislation that wasn't just trying to steal your money, they were actually forcing you to cut emissions and cutting them down to 2000 levels, which was before they were tripled by the Chinese. You'd have to have cooperation from them to even accomplish this. But look where the temperatures, the purple line is where the actual temperatures ended up. This is where we're at now. We've had warming, but it doesn't come anywhere close to any scenario in these stupid climate models. And yet, these public officials are trying to use these models to make public policy with. Is that a smart thing to do? They're failures. And there's a lot of reasons why I can tell you they fail and why they would continue to fail, but we just don't have the time to get into that discussion right now. But this is what Richard Feynman was talking about as proof of whether you have a working theory or not. If the data doesn't match your prediction and your theory, you're wrong. And it doesn't matter whether you're partially wrong, you're wrong. You're wrong, and they don't want to admit it. They keep saying that, well, we can rely on these models, but you know what they do? They just reinitialize them, they tune the variables, and they just try to, it's curve fitting. They try to get a match to what the temperatures are actually doing rather than doing real science. If they had real science, their closed model, you shouldn't have to adjust anything. You just put in the initial variable, CO2, and you'll get a prediction. And they don't know near enough about how the climate system works to do that. This is a grossly simplified model that they like to mask as being complicated, the best we've got, and I'm here to tell you the best ain't good enough. Atmospheric science has known this for quite some time. So to conclude, knowing all these things, I say the debate is over, like Al Gore. Global warming is man-made because the issue is man-made, the data is man-made, and so is the crisis. Thank you.
What you see here, my first slide, shows what the other side proposes to be the problem. The Earth is burning up, and what they've done here is they superimposed a picture of the sun on the Earth. And certainly it is true in some sort of vague sense that portions of the Earth are always hotter than normal, some portions, and some portions are colder than normal. For instance, Australia has been unusually warm the last month or so, with bushfires that are of substantial extent. Now, that's been in the news all over the place. What hasn't been in the news is that there's been a great deal of cold in other areas, and that's what is characteristic of the climate, characteristic of the weather. For instance, Greenland, just a few weeks ago, set an all-time record low at Summit Station, which is the National Science Foundation station on the top of the Greenland ice cap. It was 87 degrees below 0 Fahrenheit, about the same time that Australia was burning up. The other side doesn't like me to point out this, and yet it's the way weather works, it's the way climate works. We live on a planet with vast oceans and atmosphere that are never, ever in equilibrium for a number of reasons, but particularly that they are fluids. Now, what I'm talking about tonight is science, but H.L. Mencken, and you can tell from the way he parts his hair and what he's wearing, that he comes from a century or so ago, a famous journalist, although I'm talking about science, he realizes that this business of scaring humanity is ultimately politics, and you all know that better than I do. Ultimately, what we're talking about tonight is about politics and not about science. The whole aim of practical politics is to keep the populace alarmed and hence clamorous to be led to safety by menacing it with an endless series of hobgoblins, all of them imaginary. The urge to save humanity is almost always a false front for the urge to rule. And that's very true of our democratic betters in this state. Now, one thing we need to get straight is who are the scientists and who are not the scientists. Well, these are some of the famous scientists of the 20th century, and you will recognize some of them. Marie Curie, Albert Einstein, Max Planck, Richard Feynman, Ivar Giaever, who is a Nobel laureate in physics. You probably don't recognize him as much, but he's very much supportive of our perspective on global warming. Barry Marshall and Robin Warren, Nobel laureates in medicine, 2005, for discovering the cause of peptic ulcers. These are not Nobel laureates, but they are famous. This is an astrophysicist like I am, Alfred Wegener. He is known for what is called in German continental Verschiebung, continental drift. He hypothesized that. He didn't live very long, and it took the English, who were in charge of this sort of thing, 60 years to accept the fact that the continents drift. But he had lots of contributions to science, very important ones. This is one of my professors from the University of Chicago, Eugene Parker. he's still alive, age 95. The recent probe sent to explore the sun carried his name, which is unusual because he explained much of the astrophysics of the solar system. This man is interesting, a lieutenant in the Norwegian Air Force, somebody I happen to know also, University of Chicago professor, who in 1944 persuaded Ike to put off the invasion of Normandy from the 5th of June to the 6th of June. All of his other meteorologists said, you've got to go on the 5th of June. But this man, based on the science, persuaded Ike to go on the 6th of June. It was successful. The 5th of June was miserable. We would have lost many thousands more men, or might not have succeeded at all. So these people are all exceedingly important in science, very different from politicians. Does anybody know which one received 2 Nobel Prizes? There's only one person who has ever done this in the sciences, who amongst these people managed to do it twice. Anybody know? The only one who is out of place here. This is, physics is a man's game for the most part. But Marie Curie, 2 Nobel Prizes in physics. Quite amazing. Now, just for contrast, these are not scientists. Happy-go-lucky, very sure of themselves. They want to tell you what the science is. They won't listen, and they just tell you the science is settled, or the consensus is on their side, or they don't say anything coherent as is characteristic. The man who is most responsible for pushing the climate swindle is a man by the name of John Cook. He has a PhD in cognitive psychology, and he very much studies how people make decisions on this. And what he's famous for is this statement that there's a 97% agreement amongst climate scientists that humans are causing global warming. Now, that man has some background in physics, and he should know that science is not settled on the basis of a vote of hands. We don't say, how many people think the Earth is round, how many think it's flat? And we don't decide things on that basis at all. And yet, he knows that most people who are political in nature decide things on the basis of head counts. That's just completely contrary to science. In questions of science, Galileo got it right because he was beat upon by the Catholic Inquisition. In questions of science, the authority of 1,000 is not worth the humble reasoning of a single individual. What you get from me tonight is the humble reasoning of a single individual. And in the 1600s, that was Galileo in about 1600. In 1650, the first of the scientific societies came along, the British Royal Society, and their motto, which they pay no attention to today, is that is nullius in verba, take nobody's word for it. It expressed the determination of the fellows to withstand the domination of authority, to withstand what Galileo had to face, and to verify all statements by an appeal to facts determined by experiment. They're trying to get us away from that again today. We've had 400 years of science since then. It's been extremely successful, but the political crowd wants to move us back basically to before 1600, to the Dark Ages, where religion and politics rule today. Science is a different pursuit, completely different. So what I'm talking about here is the climate swindle. You can call it the climate fraud. It is a dangerous misuse of science. Substitute any word here that seems appropriate for you. I'm from the University of Chicago. You can reach me at hotmail.com. The primary import of what the other side says, and there are scientists who support this, well, they kind of tacitly support the idea of a catastrophe, but when you corner them, as the BBC did with the recent past president of the National Academy of Sciences, Ralph Cicerone, he said, we don't have that kind of evidence in terms of catastrophe. The difference between scientists on the alarmist side and our side is that we believe that the atmospheric response to carbon dioxide is minimal. They believe it might, for a doubling of carbon dioxide, produce 2 or 3 degrees centigrade in warming. So it's a matter of a little bit one way or the other, but we like to fight about tiny things and see how they eventually turn out. That's not useful for people interested in the political sphere. It's something that's academic. This man, Thomas Huxley, was a famous 19th century biologist known as Darwin's bulldog. He really pushed Darwin's idea of science over religion. That science was different from religion. But he also fought with Darwin all the time about the theory of evolution. And his comment here, the great tragedy of science is the slaying of a lovely hypothesis by an ugly fact. Well, we have a lovely hypothesis, and then we'll talk about some of the ugly facts that take it apart. This is the lovely hypothesis, and it's the logic that fools most non-scientists. And the statements are all true except for the last one here. It's just what ties them together and the other things that are not said there that are necessary to explain the whole situation. Well, we certainly discovered in the 1850s or so that fossil fuels were much better for running steam engines across the country and trains rather than chopping up an awful lot of wood and trying to run it off of wood. So fossil fuels delivered, and of course with Henry Ford and the automobile and whatever, we really got into the modern world. Fossil fuels deliver great prosperity. Okay, but that means that we expand industrialization, which particularly happened after the Second World War. Atmospheric carbon dioxide measured at Mauna Loa showed an increase. Now, was that due to us or was that due to Mother Nature? They want you to think it was due to us. Carbon dioxide is certainly a greenhouse gas. It certainly behaves as advertised, but it's a little deal, not a big deal. And the planet has warmed, but only a little bit, and they want you to think that disaster looms. That is not correct at all. What are the ugly facts? And there are many I could go into here, but I'm just going to hit three of them. Chuck really talked about the first one in depth, so I won't cover it that much. But humans are responsible for at most 10% of atmospheric carbon dioxide. The observed increase is therefore largely natural. Now, Chuck was talking about a number more like 4.5%, 5%. We don't know the real number, but the argument I will present to you here is that it has to be less than 10%. Okay, the other thing is the carbon dioxide hypothesis. All of this global warming, anthropogenic global warming nonsense is based on climate models, which take into account all the big details and the little details are fine. I mean, you can look at the scientists who propose this and say, fine, you're smarter than I am, but let's run a test. Let's see if we run this out into the future, if it matches the data. That's the way science works, and that's what they don't want you to do because it shows that the models are in fact running far too high. Okay, well, but let's say there's still some people in the audience, we might even have a Democrat in the audience, who said they believe the nonsense about the carbon dioxide driving up our temperature. What can we do in Oregon to change that? And every scientist who is the slightest bit quantitative will tell you that Oregon is a minor player in human emissions. We are 1/10 of 1% of the human carbon footprint. That is 1 part in 1,000. So that if you eliminate everything that goes on in Oregon, all the driving of motor vehicles, all the heating, all the respiration, humans breathe out quite a bit of carbon dioxide. We manufacture cement, that produces quite a bit of carbon dioxide. If we eliminated all of that, went back to living in the 19th century or worse, what difference would it make? It wouldn't make any difference, whether you think carbon dioxide is diabolical or whether you think, as I do, that it's relatively benign. We simply are not important enough. Sorry to say that, but we're not important enough. Okay, let's get it to change here. The first thing was what Chuck talked about, so I won't go through this very much, but are humans driving up atmospheric carbon dioxide? The short answer is yes, but the longer answer is not a lot. What is the evidence for such a radical departure from conventional wisdom? And I should mention that not all scientists, even on my side, agree with exactly what we're saying here. It takes a long while for new ideas to be accepted. What I will point out is that the atmosphere leaks carbon dioxide like a sieve. Chuck was showing what happened after the hydrogen bomb test up to about 1963. The artificial carbon dioxide that we produce in the atmosphere went out very quickly. And much of what we talk about is based on that. It simply doesn't stay there very long. So if you, 15 years ago, were driving your 57 Chevrolet and spewing carbon dioxide out all over the place, you're forgiven for that because it's gone. It's out of the atmosphere. Now, okay, it leaks like a sieve, and we have ample proof of that. Yeah, we did. Yes, we did. Okay. This is a slide I took from one published piece that was just set up to show that glacier shortening began about 1830, where our use of fossil fuels really didn't take off until after the Second World War. But what I'm interested in here is we can add up all of the carbon dioxide that went into the atmosphere there from the period where measurements at Mauna Loa began, which was 1959, up to 2019, a nice 60 years time frame, and see how much humans contributed to the atmosphere. Let's see here. Well, this is what Mauna Loa measures, and as Chuck mentioned, it's a curve that's been going up. It's a sawtooth curve because of the seasonal variation, and it's just been gradually accelerating. The question is that mostly human or mostly Mother Nature? Well, Chuck pointed out here what I call the Chinese experiment. We really are, and ought to think of ourselves as indebted to the Chinese. We're starting to build coal-fired power plants like crazy, starting about 2002, bringing many online, because they have done the experiment that Kate Brown wants you to do, but they did it in the opposite direction. They simply increased carbon dioxide going into the atmosphere. She wants you to decrease it. Well, if we go back to the last slide, how much difference did it make when the Chinese started doing things radically different in 2002? Nothing at all. Mother Nature didn't take notice of anything. So do you think she's going to take notice of your starving yourself for fossil fuels, or putting no carbon dioxide into the atmosphere? No. Mother Nature is on her own program here, and we need to realize that we're not as important to this planet as we think we are. We've got these egos that say we're massively important, but we're really just like ants running along the ground. We're kind of like fleas on a dog. We're irritating the dog, but we're not killing Okay. Now let's do a little accounting. I don't like getting numbers very much in these presentations, but since the carbon dioxide measurements began, and these are good carbon dioxide measurements with an IR technique, a brand new technique in 1959. We have since that period of time, over 60 years, released 400 gigatons, 400 billion metric tons into the atmosphere, a lot. Mauna Loa, though, has only measured an increase of 200 gigatons. What happened to the other 200 gigatons? Well, the answer is that CO2 leaked into other large reservoirs on this planet. Hence, humans are responsible for less than 10% of the carbon in the atmosphere. Well, how do I get that? And this is my little diagram here. The atmosphere, I show 800 gigatons in the atmosphere. I think Chuck wanted more like 900 gigatons. But here we are up here putting in only 10 gigatons into an 800 gigaton reservoir. That is feeding into the biosphere. Remember your high school biology that photosynthesis from plants pulls carbon dioxide out of the atmosphere, produces plant material, and then a cow comes along and eats the grass, then we eat the cow or we drink the milk or whatever, and then that process goes on. Of course, the cow dies, the grass dies, we die, and we go back to carbon dioxide in the atmosphere. So it's a cycle of that sort. Also, the oceans absorb carbon dioxide, much as my glass of water here, as it warms up, will absorb carbon dioxide out of the atmosphere. It becomes a little bit acidic as a consequence, but oceans are vast, covering 70% of the planet. So this is the general circulation of carbon dioxide, but there is also a graveyard for carbon dioxide in the deep oceans of containing 38,000 gigatons. And we know that the rate of exchange between the ocean surface and the deep oceans is about 40 gigatons per year. My calculation was very, very simple. I said, let's forget about this, because this isn't a very substantial rate. Here we have 100 and 110. That makes it 5%. But if we look over 60 years and assume that what we put into the atmosphere has mixed into these reservoirs also, we have about 4,000 gigaton reservoir, of which we have added 400 gigatons too, so that's where I come up with the 10%. We can be at most 10%. These numbers from the UN IPCC, from our opponents in this argument, show 5%. I show at most 10%. I think the answer will probably settle out somewhere in between. Still, we are minor contributors, so whatever you do, whether you're driving a great big Hummer or an electric vehicle, it's not going to make much difference. The atmosphere is not going to make much difference to Mother Nature. I'd like to point out that carbon dioxide is very beneficial. That's part of what we do with the CO2 Coalition in Washington, D.C. Because carbon dioxide is the basis of life on this planet. And I've kind of gone through what that is already. In fact, from NASA satellites, we can measure a greening of the Earth that has occurred over the 1982 to 2015 period. So the more carbon dioxide you have in the atmosphere, the better plants grow. Farmers know that. If you buy tomatoes, the chances are these days the tomatoes come from greenhouses. The chances are the farmer who's growing them in a greenhouse runs the carbon dioxide up from the ambient of 400 parts per million to around 1,000 to 1,500 because plants grow a lot better and faster at that point. This shows it worldwide. However, I want to point out that you can't take credit for that because that's mostly Mother Nature. Mother Nature's driving up the carbon dioxide. We are not. What about temperature? Well, these are the best measurements we have of the global temperature showing the annual cycle. In summer it's warm. For the entire planet, our summer, not the southern hemisphere summer, our summer, is warm in July and it cools off into December and January. That varies a little bit year to year. This particular year, 1998, is the warmest one in the 40-year satellite record. If we relate that to what we expect, this is an average of the 1981 to 2010 data, we get this plot, which is exactly the same from the same data, it just looks a lot different. It shows what's unusual in the Earth's temperature. For the lower troposphere, it shows again 1998 is a very interesting, substantial year, an El Nino year, and it's a word you become familiar with, warming of the water off the Pacific coast of Peru causes these spikes in the global temperature. It also occurred in 2010. It also occurred in 2016, and you notice the global temperature is going back up. This is not correlated with an El Nino. We're off the El Nino cycle. It's kind of an out-of-season El Nino, but again, an ocean effect, not a carbon dioxide effect. There is some slight increase here. You saw it in the other plot also. It could be carbon dioxide. It could be an ocean effect. But tiny, tiny temperature increases. Notice they are fractions of a degree centigrade. Not terribly important. And this shows the El Nino situation. This shows the warming off the coast of Peru. And here's where there's been the warming over a period of time from 1900 to 2000, over 1 century. And this is due to Nate Mantua at the University of Washington, who was studying the migration of salmon, the effects of ocean temperatures on salmon. He basically put all of this together, and of course it's very useful in understanding climate, because here in the 1930s to 1940s we were into a hot period. Here we were into a cool period. We're now into another warmer period. Those are ocean oscillations. Why are ocean oscillations important? Because the oceans contain most of the mobile heat on this planet. They cover most of the planet, and they contain most of the mobile heat. The first 10 feet of the ocean contain as much heat as in the entire atmosphere, but of course they're much deeper than that, and they have a vast amount of heat that they can either fold down to lower layers or bring back up to warm and cool the planet about some sort of medium. Okay, now we come to the comparison of the climate models with actual data. This is the nitty-gritty, and this shows the climate models, all 102 of them average, show from the beginning of the satellite era, about 1979, that the temperature should have gone through the roof. This is what happened. This is the satellite data, and this is radiosonde data, which is a completely different measurement. So it shows that the satellites are working, that they're producing something very similar to what radiosondes, these are little balloons with instruments that go up into the, in this case, tropical mid-troposphere. where the alarmists say the biggest effect should occur. In fact, it doesn't occur. And this says that the whole idea of warming is wrong, Now how do they respond to this when you point that out to them? Well, they'll say, look, the data is wrong. The theory can't be wrong. That's not the way we do science. If you did science that way, you would have somebody say, I have a cure for cancer over here. The data shows that it doesn't work. We have to redo those trials to see if we can torture the data enough to come out with something that indicates that my theory or my cure for cancer works. That's not science, and if that takes hold, it's taken hold with Democrats. If it takes hold, science is dead. Okay. I like this explanation from Gerhard Gerlich, who's a professor of mathematical and theoretical physics in Germany. To derive climate catastrophes from these computer games and to scare mankind to death is a crime. And he explains why here, somewhat humorous. Hence, the computer simulations of global climatology are not based on physical laws. They're games. And he recognizes that they're useless in predicting the future. But let's see how they manage to doctor the data to try and bring it in line with the climate models. This is the U.S. Historical Climatological Network data in blue. They go through and adjust it such that they cool the past, and then by golly, it goes up over time. No, that's not science. This was done just prior to the Paris Climate Accords. Obama and I think it was Holdren were in touch with the people over at NOAA saying, you've got to get rid of this flattening that occurred after the Super El Nino of 1998. You've got to bring the temperature back to continually going up. So they found various corrections that they could make to the surface station data so they continued to show temperature increasing. So you continue to be worried and are willing to sign on for whatever they want. That's not science. Okay. Now, there have been other predictions here that are interesting in that they've been total failures. 1988 was James Hansen and his saying that, gee, we've got to pay attention to carbon dioxide in the atmosphere, we're headed for catastrophe. He said scientists were 99% certain of future drought. Well, indeed, it was dry in 1988. But look at what it's done since then, and look at the trend in precipitation across the contiguous U.S. That's the 48 states. It's been going up. So it was exactly the opposite of what he showed. Not that we haven't gone back to dry years. We've had some dry years, but the climate is cyclical. It's cyclical because the oceans and the atmosphere are cyclical. Now, this is interesting because this is Governor Inslee. We don't have the only idiot governor on the list. This was last year, and Inslee noticed that it was dry in western Washington, so we have to declare a drought emergency. Now, there must be a drought across the entire United States. No, in fact, it was one of the wettest years in our history, but 30% of this country is typically in drought. Not this particular year. This was indeed the lowest incidence of drought in U.S. history. Okay. This is what drought really looks like. This was May 1934. It was rather different. Then you could complain about things being very substantially dry. But notice over here, Governor Inslee's Western Washington was just fine in 1934. Things do change. Fortunes do change. What about world record high temperatures? Neglect the one from Africa. It's been discredited. The highest temperature ever recorded on this planet, legitimately, 134 degrees Fahrenheit, Death Valley, California, 1913. What about Australia? It's been hot in Australia. The record was 128 degrees Fahrenheit, set in 1889. Europe, 1881. South America, 1905. Oceania, 1912. Antarctica, fairly recently, but only because nobody was there. So, in fact, all of these records were set long ago. Again, it says that if we're warmed, we haven't warmed very much. So we don't need to worry about our own carbon dioxide from that particular perspective. What about state record highs and lows? Anybody know when the record high for Oregon was set? Which of these has Oregon? Well, the hint is it's over here. 10th of August, 1898, it was 119 degrees Fahrenheit in Pendleton. We're not sure that's exactly accurate, but it's pretty close, and it was pretty hot, and it was a long time ago. So, Kate Brown, don't worry about things out here. I think the low temperature here was a 50 below zero in Maine. These are low temperatures, these are high temperatures, and a number of them. Again, the decade you didn't want to live through was the Dust Bowl of the 1930s. Again, nothing suggesting that anything unusual is going on today. What about extreme weather? This is a presentation from a friend of mine, Matt Kandikar, to the Chinese National Academy of Sciences a few years ago. And he's saying, are extreme weather events on the rise? The short answer is no, and the long answer is no, no, and no. I don't know how that translated into Chinese, but I think they rather like it. Extreme weather events have always occurred on in the Earth's climate. The present concern vis-a-vis global warming is more media hype than reality. Present or future extreme events pose no, and then I added increasing threat to humanity. They certainly pose threats because hurricanes and tornadoes and whatever are still occurring and will continue to occur, but their frequency hasn't increased. In fact, it's decreased. This is something he pulled out. He's from Canada, Environment Canada, actually. Worked for them for many years. He pulled this newspaper article out about, it was like we were living in a furnace. It talked about the magnificent heat wave in Toronto, where I think 1,000 people died, yeah. Deadliest heat wave in Canada, 1,100 people died, July 1936. Nothing recent. And that was probably because they didn't have electricity, they didn't have air conditioning. And we have that. So don't let Kate Brown run up the price of air conditioning so she can turn it off. We can get hot temperatures here. We've been up to 106, 107. You need air conditioning for that. That's the way you survive. Okay, but they'll say, yeah, maybe all of that's true, but what about sea level? Aren't we in danger of flooding particular islands in the Pacific? Well, there are some places in this world where land is sinking, and as a consequence, the sea level looks like it's going up. It's certainly getting their feet wet. There are other areas where land is rising, and it looks like sea level is declining. If you can sort out that from the real sea level rise, we are still coming out of the last ice age. If you lived in Seaside, Oregon 15,000 years ago, you would not be able to see the ocean. It was so far out. Massive continental glaciers melted, and sea level rose hundreds of feet. Now it's just tapering off to practically nothing. This shows that over the last 150 years, depending on what measurements you believe, these are tide gauge measurements, simple measurements. These are satellite measurements here with actually satellite measurements here, and I forget what that purple curve is actually, but different measurements, they match until up in here, and then there are different ways of interpreting the satellite data, so you don't know really what's happening with sea level. It's hard to measure because the ocean varies by 40 feet. You have 40-foot swells in some areas. You have high pressure areas which tend to depress sea level. You have low pressure areas which tend to suck it up a little bit, and sea level is higher. Okay, trying to adjust for all of that over a century's time. How much have the sea level increased? And it is increasing. Well, anywhere from essentially nothing to 10 centimeters, or about 4 inches. Not a big deal. Not a big deal. Well, and then we always get into discussion. This is a different subject in the sense that it's not even a thermal subject. This talks about ocean acidification. The oceans are basic. There is no place that they are acidic. My glass of water here is acidic because it's fresh water. But seawater is buffered. The pH is always from neutral 7 up to 8. That's alkaline. That's alkaline. And this is the data. I like data. I'm an experimental physicist. I'm not a theoretician. A ship went from Hawaii to Alaska and measured from the surface all the way down to the bottom. This is the bottom of the Pacific, measured the pH. You can see here where the water is warm, the pH is a bit higher, a bit more alkaline. You can see here it's got more carbon dioxide in the water, and it's a little bit lower pH, but it is still above 7, it is still out. So this whole business of ocean acidification is a farce. It is just not something that is happening at all. No, I shouldn't say at all. It's happening tiny, tiny bit. It has no consequence for marine life because atmospheric CO2 levels have been far higher than what they are currently in the past, and even delicate corals have survived for hundreds of millions of years in those conditions. Well, then alarmists will drag us into the polar regions. Are the polar regions melting? What about Antarctica? And this is Antarctica. And if we go to West Antarctica, the blue and green areas here are losing quite a bit of ice. Why are they? Is it particularly warm there? Well, yeah, it's warm. That's because there's volcanic activity under the ice that comes up occasionally and melts some of the glaciers, dumping it into the ocean. But the rest of Antarctica is actually gaining mass, ice mass, and in total, in this study, it went up by 82 gigatons per year over that period of time. A gigaton is an ice cube. It's an ice cube 1 kilometer that way, 1 kilometer that way, and 1 kilometer that way. Very big ice cube, lots of ice, but nothing compared with what is already stored in Antarctica. The coldest place on Earth is Vostok, the Russian base, which is about here. There's the South Pole, the U.S. base. These places are typically, I think Vostok is typically 65 degrees below 0 centigrade. It is a very cold place, even in the summertime. There are other studies, the other side will point to studies that show some slight decrease in the amount of ice in Antarctica. It's all within our ability to measure. We can't do that good a job. The amounts, the change there is very, very slight. Again, nothing to worry about, nothing that we're responsible for. What about looking back in time to previous periods? Are we particularly warm today? They want you to believe that we are. These are the temperatures derived from the ice cores in Greenland. And you notice that the warm periods during this is the Holocene climate optimum. The Minoan warm period was considerably warmer than today, and this is today here. The Roman warm period, another civilization, that's essentially the Greek civilization, the Roman civilization, the medieval civilization where we came out of the Dark Ages. All the warm periods, humans have done better on this planet. Then it cooled off, and then we have warmed up again for a modern warm period. What causes these? Certainly not human emissions of carbon dioxide, not carbon dioxide at all. Probably changes in solar activity, but we don't know for sure. What we do know for sure is that these periods, this goes back, instead of going back just a few thousand years over the period of human history, this goes back essentially 500,000 years, again from ice cores, this time in Antarctica. It shows the very periodic behavior, where you get out of an ice age for a little while, and then you step down into another ice age, and then suddenly you come out. And that puzzled people for a long while. A Serbian physicist by the name of Milutin Milankovic figured out that this was in fact an astrophysical situation. Again, not carbon dioxide. Here is the Holocene climate optimum where all of human civilization developed. Just right here, this is the birth of Christ, so we're right in that period. We're unusually warm. What causes the changes in the Earth's orbit that produce these ice ages? It's basically the planet Jupiter, which is more than twice as massive as all of the other planets in the solar system combined. So it even drags the sun back and forth across the center about the center of mass of the solar system. About 7 Earths would fit in the giant red spot here. So it's massively larger than anything else in the solar system aside from the sun. And this is a complex graph, and I won't explain all of it, but this is, again, shows the temperature derived from the ice cores, and the fact that we, over the last period here, the previous interglacial, here is the present interglacial, temperature went down, 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 due to, well, that's complex too, but due to the Earth's axis is tilted with respect to the plane of the ecliptic. It points to the North Star over 25,000 years. It goes all the way around the heavens and comes back to pointing at the North Star. That changes the seasonal closest approach to the sun, which changes the whole input to the Earth's system, and it gives us over 5,000 year periods a great summer, which brings you out of an ice age basically, and then you have great winters and you get deeper and deeper into it until suddenly something happens that gets you out. And this is very recent work. What gets us out? And it turns out that the yellow is carbon dioxide. Carbon dioxide gets very low. You don't have much carbon dioxide in the atmosphere. You don't have much in the way of plants. The great deserts like the Gobi Desert in China turn to dust. You see massive amounts of dust in the ice. That coats the continental glaciers, changing their reflectivity from white to black. They start to melt, and the temperature shoots up in the next great summer. So it's an interesting explanation of how we get out of ice ages. It even has a carbon dioxide connection, but it's the carbon dioxide connection to life, not to climate. This is a Russian. I've heard him speak. He must speak perfect English, but I can't understand a word he says. He studies changes in the output from the sun. Habibullah Abduzamatoff. Carbon dioxide is not guilty, and as for what lies ahead in the coming decades, it's not catastrophic warming, but a global and very prolonged temperature drop. Where does he get that? Well, he looks at sunspots and other indications of solar activity. The sun is a variable star, but it varies very little. And when a lot of sunspots, it's a more active sun. It puts out a little bit more in the way of radiation, and it puts out magnetic fields that exclude cosmic rays from the inner solar system. That has effects on our climate. The measurements of sunspot activity. These are the oldest measurements kept by man, even older than temperature measurements, begun in 1611 by Galileo. Kept going during this period here by monks in monasteries that I guess after their morning prayers had nothing better to do than to look up at the sun and count the number of black spots on the surface of the sun. They realized that when you had a more active sun, you had warmer conditions. And you can see from about this period here, well actually from about 1800, we came into another Dalton minimum here where the sun cooled off, and then we have rather steadily until in here near the turn of the century, solar activity increased, and that is likely what is related to the modern warm period. There was probably something back here with the medieval warm period, but we don't have the data, so we can't tell for sure. In other words, that is another driver of climate that is significant. This is the prediction from Abduzamatoff and the Russians that we are headed into another Maunder minimum, which was a cold period, and this prediction has actually not come true. It's further down than that. So solar activity is slacking off. We're headed for colder times. Okay. Then the last thing is, what about Oregon? If you're alarmist or if you're skeptic, we're still responsible for essentially nothing that's going on a global scale. That means nothing that we do will have any effect on our climate at all. So whether you pay high carbon taxes or no carbon taxes makes no difference in that regard. Makes a big difference in other regards, but it makes no difference in that regard. Stopping all fossil fuel emissions via carbon tax will not affect our climate, but will heavily impact our way of life. You know that better than I do. Faking the science is disastrous in so many ways. That's what the Democrats are doing. I hate to say that. I mean, the science is profoundly non-political, and I've got friends who are an Englishman who's a socialist. Fine, but we're very much together on the science. We don't agree on economics, but we agree on the science. That's the way science should work. It doesn't work, though, with all the money that has been flowing into the whole carbon business. It's a $1.7 trillion per year business in this country. The oil companies are small by comparison to what these folks are doing to us with their windmills and solar cells and whatever. But those don't provide any net benefit to the society, incidentally, but that's a whole other story. Carbon dioxide is remarkably beneficial, and this is important to realize. You don't want to be afraid of it. Carbon dioxide in this room, incidentally, because you people are here, has gone up from 400 to easily 600 parts per million. It's the gas of life. It's a minor greenhouse gas. Chuck explained in detail why that is. If it does drive up the temperature at all, warmer's better anyway. We're much better off in warm periods than we are in cold periods. At 400 parts per million, the current level, we're near 200 parts per million, the minimum needed to support life on this planet. So the danger is we have too little, not that we have too much. The current level helps feed mankind. You probably know something about Norman Borlaug, the great agronomist who helped India, Pakistan, and Mexico become self-sufficient in food by producing seeds that were better adapted for those particular climates. But the other thing that helped him was the increased carbon dioxide in the atmosphere made it much easier for farmers to grow more in the way of crops, get more yield per acre. But those I'll come forth and say, well, carbon dioxide is harmful to people. Well, it is. We're poisoning ourselves because if I hold my breath and breathe out, I'll breathe in air at 400 parts per million. When I breathe it out, normally I'm breathing out about 40,000 parts per million carbon dioxide. If I hold my breath, it goes up to 80,000. So that's not unlike an automobile and other devices that make our lives much better. Well, but what about people who have to live in an artificial atmosphere for a long period of time? What about the U.S. Navy? What about the submariners who can spend a year under the ice in the Arctic to avoid the Russians detecting them? We have the ultimate doomsday machines with these nuclear-powered submarines that carry more ordnance on one submarine than was expended in all of the Second World War. So they can fight an enormous battle for us if otherwise we were hit hard by the Russians or the Chinese. They have to maintain the atmosphere in the submarines to maintain life, to keep the crew going well. That's maintained at not more than 5,000 parts per million. So we got a long ways to go before the U.S. Navy would be concerned. Previous levels in the atmosphere have been very high, not 400 parts per million that we have today, which is low. They've been up to 7,500 parts per million. And then as Chuck mentioned, and as Ed Berry mentions, and as I've mentioned, humans emit 5%, Mother Nature 95%. Okay, I'll end this with a quote from a socialist. Now, you don't mind that, do you? He was a socialist who understood some of the problems of socialism, particularly some of the problems of communism, George Orwell, with his novel 1984. Some ideas are so stupid that only intellectuals believe them, and I think his whole business of global warming is that. They've sold it very effectively, but it is entirely rubbish. The climate is not coming apart. And it seemed like it was getting a little cold to me today, but the climate's not coming apart. This is winter. It's supposed to be this way. So thank you very much. I'll be happy to answer questions. But if you've got difficult questions, Chuck is much better at answering them.